The first part of this question I already did. I can show you what I did in StatCrunch real quick. That's a summary of information. They already calculated the mean for us in the standard deviation. They didn't give us the raw data. So what you want is to go to stat, and it's a t statistic because we're dealing with a mean and we don't know the population standard deviation. So with sample data, you're almost always using t stats, unless it's a proportion. But this is a mean, so we need the t stat, and we use the summary. So I just typed all the information in here, didn't click any other funny buttons other than a confidence interval. So that's how I got the confidence interval there. So for part B, the question is asking, why is it more narrow when you have a larger sample size? Look, in this one, sample size of 30, sample size of 40, this is our confidence interval. They used a smaller sample size of 6 and a sample size of 6. They only took 6 houses in each neighborhood. And they got a way wider confidence interval. Okay, the reason for that is because of the margin of error formula. Look, you're calculating sample mean 1 subtracted by sample mean. This is what StatCrunch just did behind the scenes for us. This is the margin of error. And the standard error is this right down here. Okay? So if you have a larger sample size, you're shrinking the standard error. And so therefore you have a smaller margin of error. Therefore, the number that you add to the mean difference is going to be smaller. So the distance between these two numbers will be smaller. Okay? Now actually it's tough because t increases when you have a smaller sample size. So I wonder, I haven't really looked at the options. If you look at a t table though, let me see if I got one. It's not. Yeah, that's the question we're working on. I think I looked it on up here. T table. Look, if you have n equals 3, there's your t value. If you have n equals 10, you got a smaller smaller t value. So a larger sample size, wait a second, that might actually work. A larger sample size shrinks the t value, right? Okay, so a larger sample size, it shrinks the standard error. A larger sample size, it shrinks the critical value. So this is actually opposite. The original confidence interval had a larger sample size. So a larger sample size should have a smaller t value. Sample sizes are larger. That's true. Why is the confidence interval part A narrower? It's true because the sample sizes are larger. Part C, the sample means are significantly larger when there are more data values. No, that's not true. You could get unlucky and pick data values that just happen to be smaller than the other ones, so that's not true. So B has to be the right answer here. Is 0 within the confidence interval found in part A? No, 0 isn't between these two numbers. So that means there's a statistically significant difference. These two neighborhoods are statistically significantly different. What does the confidence interval suggest about the null hypothesis that the mean difference is 0? We should reject the null if 0 isn't within the interval. It means we found statistically significant evidence. These things are different enough so we can reject the null hypothesis that they're the same. Since 0 is not a plausible value for the truth. Yeah, 0 is not a plausible value because 0 isn't between these two. So we reject HO. When you make a confidence interval for the difference of two values, if 0 is in the interval, you can't say that they're different enough because they could be exactly the same, so that if you subtract them, that makes 0. If 0 is not in the interval, it means you found statistically significant evidence. These two neighborhoods are different.